A situation may arise in which you have three voltage sources, such as the mains, that is the electrical mains, and two generators. The mains is supposed to be on duty, while the two generators are supposed to be on standby. And out of those two generators, only one will be selected at a time. And now, considering the three voltage sources, the mains, the two generators, making three, it is only one that will be selected at a time. The mains will be selected as a duty voltage source, and when the mains goes off, then one of the two generators will be selected. So how will that one be done without any operational disconnection or connection? So it's going to be done through the use of mechanical interlocks. So by any operational disconnection, what I mean is that without touching any wire or any cable before the interlocking system or before the changing over system will be achieved. The interlock makes use of model case circuit breakers. Okay, so but it is synonymous to the changeover switch that we are all familiar with. All right, so and it can also be that there are three identical loads. So and out of those three loads, one of them is to be selected, or it could be two of them to be selected at a time, while the ones that are not selected will be on standby. So if it is only one that is selected, two will be on standby. If it is two that are selected, the remaining one will be on standby. So and the situation will be handled by making use of mechanical interlocks without making use of any operational disconnection or connection. This video precisely is all about mechanical interlock for selecting one out of three voltage sources, and also for selecting one or two of three identical loads without any operational disconnection or connection. Any disconnection or connection that needs to take place just before a particular operation can be effected is what I call operational disconnection or connection. In this situation, we are not going to make use of any disconnection or connection, but it's going to be purely through the use of mechanical interlocks. Please do subscribe to my JK Multimedia Solutions channel and follow me in this video as I go ahead with illustration. Now, moving on with the example. Interlock system for three voltage sources and three identical electrical loads. Alright, the voltage sources, that is the three voltage sources in this situation, they are the mains, generator 1, generator 2, while the identical electrical loads could be chillers, three chillers, identical three chillers. Two could be on duty while the other one could be on standby. Now, the illustration. A particular low voltage, that is LV installation or electrical system, is to have electrical mains as the main, that is the main or major voltage source. That is the duty, it will always be on duty. While a generator and another generator, making two generators, are to be on standby. The system / installation has three identical loads and some other loads. One or two of the identical loads is or are to be on duty, while the remaining ones, okay, if it is only one, it could be one or the two. So the remaining ones will be on standby by using mechanical interlock system without any operational disconnection or connection. Now the main question is draw power distribution schematic diagram for the system. Now, as I make progress, let me talk about mechanical interlock. Mechanical interlock, mechanical interlock, mechanical interlock, mechanical interlock. And these are the technical representations of a mechanical interlock. Alright? So basically, this is a single line representation of mechanical interlock, single line diagram, and this is 4-line diagram or 4-line representation of a mechanical interlock. Basically, a mechanical interlock comprises two model case circuit breakers, MCCB1, MCCB2, and they are coupled together in such a way that the two circuit breakers cannot be switched on at the same time, but they can be switched off at the same time. Alright? So moving forward, as I said, a mechanical interlock has 3 stages in usage. The first stage is when the left hand side circuit breaker is switched on, and simultaneously this right hand circuit breaker is switched off. The second stage is when this right hand circuit breaker is switched on and the left hand circuit breaker is simultaneously switched off. And the third stage is when the two circuit breakers are in off position. None of them is on. So a situation where the two circuit breakers will be switched on at the same time does not arise. It is forbidden. It doesn't exist. So they are interconnected in such a way that only one can be switched on at a time, while the two can be switched off at the same time. Actually, the power distribution schematic diagram that we are looking for is this. But before I go on to explain it, let me explain the detail on this circuit breaker and on this circuit breaker. So, looking at this one carefully, one will see that this set of cables is joining at the upper side, the upper part of the circuit breaker. Similarly, this set of cables is also joining on the upper side of this circuit breaker. Okay, this is the lower side of the circuit breaker, the lower side, this is the upper side, and this is also the upper side here. Now, this MCCB is what I've brought out here. So this MCCB is this, and this one is this one, and the entire interlock itself, interlock 3, is this one. Why the mechanical interlock 1 is this one, alright, and this one. So this one is the 4-line diagram or 4-line representation of this, and this is the 4-line representation of this one. Now, since we have the set of cables joining on the upper part or the upper side of the circuit breaker, this circuit breaker is this when it is drawn in the 4-line diagram form. So that's why we have the cables joining on the upper part. So here also the cables are joining on the upper part, and that is what I want to explain. And these are the details on this circuit breaker and on this circuit breaker. Now, this is the power distribution schematic diagram. And we have the mains, generator 1, generator 2. And these are the 3 voltage sources. So this side, this is the load side. Load 1, load 2, load 3, load 4, load 5. Basically, we have the 3 identical loads, being load 1, load 2, and load 3. Load 4 and 5, they are the other loads. Alright. Now, the green box represents the LV, low voltage MCCB panel. Now, normally, it is always the mains that is being used. So, to select the mains, this circuit breaker will be closed, and according to the explanation that I gave for the mechanical interlock, once this circuit breaker closes, this one opens, and then power is supplied to these bus bars. Okay. Now, if there is mains failure and generator 1 is to be selected, this circuit breaker will be closed, and automatically this one will open. So, and also this one will also close, and this one will open. So, and there is power supply to the bus section here. Now, if it is generator 2 that will be selected, this circuit breaker will be closed while this one will open. And at the same time, this circuit breaker, all other circuit breakers will be opened, just as we have this one being closed. And that is about the selection of the appropriate voltage source. So, out of the 3, it's only one that can be switched on at a time. So, now we look at the load side. These are the identical loads. Load 1, load 2, load 3. Now, what we are saying is that, assuming we have 3 identical chillers in the chill water system, we need to power them. So, let's say we have 2 chillers operating at a time, while the other one, the chiller 3, will be on standby. Now, to select chillers 1 and 2, we close this circuit breaker. Once we close this one will open. And for this one will be receiving power supply through this circuit breaker that will be closed while this one will open. And the current will flow through this circuit breaker to the upper part of this circuit breaker. You can always refer to the detail here for thorough understanding of what is taking place here. So, similarly, here also, the detail of what is happening here is what is explained here. Alright? So, to select loads 1 and 3, this circuit breaker will be closed, this one is opened, and also this one is open while this one is closed, and we have these 2 chillers, these loads 1 and 3 being selected. If loads 2 and 3 are to be selected, this circuit breaker will be closed and this one will open automatically. And this one will also, this circuit breaker will also be closed while this one will open automatically. So I will have these loads 2 and 3, or if they are chiller, they will be chillers 1 and chillers 2 and 3 being on. Now, this one, these circuit breakers could be closed or open as required. They are independent loads, or they are other loads. Now, what we are saying here in summary is that considering these 3 loads, 1, 2, 3, 2 could be selected at a time, or even 1 could be selected at a time. So, if 2 are selected at a time, the remaining 1 will be on standby. If only 1 is selected at a time, the remaining 2 will be on standby. That's about these 3 loads being operated making use of interlock. So as I said here, this is the metering unit, and here, as for the power sources, only one power source could be selected at a time. Two power sources cannot be selected at a time. We only require one. We only want only one to be selected at a time. For the voltage sources, to select the mains, this circuit breaker will be closed, this is opened, this will be closed, and this will be opened. To select generator 1, this circuit breaker will be closed, this will be opened, and also this one will be closed while this one will be open. And to select generator 2, only this circuit breaker will be closed, all others will remain open. Another way of selecting one voltage source out of 3 voltage sources at a time is by using an interlock to select any of the 2 generators and subsequently interlocking the output of the selected generator with the mains. Now, the detail of what is happening at the upper part of this circuit breaker is what is shown here. Now, this interlock unit, which is the generator selection interlock unit, can actually be outside this low voltage panel. In fact, it could be remotely located from it, or it could be incorporated in the low voltage panel as it is shown here. In this video, in summary, I've been able to talk about how to select 1 or 2 loads out of 3 identical loads at a time. And also, I've been able to talk about 2 options of selecting 1 voltage source out of 3 voltage sources at a time. So, the first option is the one I talked about earlier, and this is the second option that is being shown here. All right, and that is it. Finally, please do subscribe to my JK Multimedia Solutions channel and expect more superb and informative videos. Thank you.